When scientists first found this massive trail of stars, most of them thought that it was a black hole getting hindered by a gas cloud when observed from our point of view. This idea quickly fired the imagination of the astronomical community, because it needs a large set of complex exceptional circumstances. For this reason, several scientific teams have continued to explore different and less exotic scenarios that could explain the observations. However, this new hypothesis contradicts the initial idea of a supermassive black hole passing through a gas cloud, which would have caused a gravitational disturbance resulting in the formation of the trail of stars. The IAC team's theory suggests that the stars in the trail were once part of a thin, disc-shaped galaxy that merged with another galaxy, causing its central bulge to be disrupted and creating the elongated trail. The new explanation has sparked controversy among astronomers, with some questioning the lack of evidence for the merging of two galaxies in the area where the trail of stars was discovered. However, the IAC researchers have defended their hypothesis, stating that it is consistent with the available data and that further observations could confirm or refute their findings. As astronomers continue to investigate this enigmatic structure, one thing is clear: the universe never ceases to surprise and amaze us with its endless wonders. The motions, the size, and the quantity of stars fits what has been seen in galaxies within the local universe, explains Jorge Sanchez Olmeda, an IAC researcher who is the first author of the article. It is a relief to have found the solution to this mystery. The new proposed scenario is much simpler. In one sense, it is also a pity, because the existence of fleeing black holes is expected, and this could have been the first one to be observed. Upcoming observations will allow the study of this object in greater detail. However, one thing is for sure: there are a lot of things in the universe that we have no idea about. Only recently, the James Webb Space Telescope detected massive galaxies at the edge of the universe that, according to our science, should not exist. Yes, it discovered 6 galaxies that existed only 500 million years after the Big Bang. Not just that, these galaxies are well formed and contains more stars than today's galaxies like our Milky Way. These galaxies should not exist, as it toys with our model of cosmology. To make matters more uncomfortable for scientists, researchers from the University of Minnesota have discovered that one of these galaxies is so bizarre that we might have to go back to the drawing board. According to the theory of cosmic inflation, the universe was born with the Big Bang as an unimaginably hot, dense point. When the universe was just 100th of a billionth of a trillionth of a trillionth of a second in age, it experienced an incredible burst of expansion known as inflation, in which space itself expanded faster than the speed of light. During this period, the universe doubled in size at least 90 times, going from subatomic sized to golf ball sized, almost instantaneously. After that, the growth of the universe continued, but at a slow rate. As space expanded, the universe cooled and matter formed. Only 1 second after the Big Bang, the universe was filled with neutrons, protons, electrons, anti-electrons, photons and neutrinos. During the first 3 minutes of the universe, the light elements were born, during a process known as Big Bang nucleosynthesis. But for the first 380,000 years or so, the universe was essentially too hot for light to shine. The heat of creation smashed atoms together with enough force to break them up into a dense plasma, an opaque soup of protons, neutrons and electrons that scattered light like fog. 380,000 years after, however, matter began to cool, and it cooled enough for atoms to form. However, after this point, the universe was plunged into darkness, since no stars or any other bright objects had formed yet. Fast forward to 400 million years after the Big Bang, and we can see the universe beginning to come out of its dark ages. This period in the universe's evolution is called the Age of Reionization. During this phase, which lasted for more than 500 million years, the first stars started to appear. So galaxies, scientists thought, began building up in the first billion years after the Big Bang, and sort of reached adolescence at 1 to 2 billion years. However, the James Webb Space Telescope has found not one, but 6 galaxies that were fully formed only 500 million years after the Big Bang. And that is a problem. Using first-of-their-kind observations from the James Webb Space Telescope, a University of Minnesota-led team looked more than 13 billion years into the past to discover a unique, minuscule galaxy that generated new stars at an extremely high rate for its size. The galaxy is one of the smallest ever discovered at this distance, and could help astronomers learn more about galaxies that were present shortly after the universe came into existence. The galaxy's volume is roughly a millionth of the Milky Way's, but we can see that it's still forming the same numbers of stars each year. The galaxies that existed when the universe was in its infancy are very different from what we see in the nearby universe now, explained scientists. Studying these galaxies could help us figure out how and when these first stars and galaxies emerged from within the universe's dark ages. Until then, it remains a mystery still as to how the universe came into being. As days pass, more results of observations from JWST is revealing that the universe, especially at its early stage, was stranger than we imagine. Not only has Webb discovered these early galaxies, it has also now found a black hole which is almost as old as the universe. Scientists have discovered what they believe to be the oldest known black hole in the universe, owing to the telescope's ultra-powerful sensors that captured this elusive entity. This supermassive black hole, which dwarfs our Sun by a staggering 10 million times, existed at the center of a galaxy 570 million years after the universe's inception, a time so remote it's difficult to fathom. To put it in perspective, the universe itself is estimated to be 13.7 billion years old. Observations collected through the James Webb Space Telescope have revealed an active supermassive black hole 10 million times the mass of the Sun, one that is actively growing as it slurps up matter from the space around it. At just 570 million years after the Big Bang, this is the earliest growing supermassive black hole detected yet, although scientists are hoping it won't remain the record holder for long. The black hole was found inside one of the earliest galaxies ever detected, previously known as EGSY8P7, though since renamed Sears_N19. Its discovery could help with one of the biggest head-scratchers of the early universe: how the black holes in the cosmic dawn grew to such large sizes in such a short amount of time. We found the most distant active galactic nucleus, AGN, and the most distant, earliest black hole we've ever found, said an astrophysicist associated with the finding. Scientists were initially looking at Sears_N19 as part of their work investigating light produced by star formation in the very early universe. This light, called Lyman alpha emission, is thought to be generated by the ionization of neutral hydrogen by star formation activity. The early universe was filled with a fog of neutral hydrogen, which prevented light from propagating. It was only after this hydrogen was ionized that light could stream freely. This epoch of reionization, as it is known, is not fully understood. We know it took place in the first billion years after the Big Bang, 13.8 billion years ago. But seeing that far into the early universe is really hard. Sears_1019 and a handful of other super-early galaxies are excellent targets for this research because they are relatively bright. The galaxy was identified in Hubble data in 2015, and at the time was the earliest, most distant galaxy observed. Subsequent observations confirmed its existence, but more detailed information remained elusive. The earliest light in the universe has shifted so far into the infrared part of the spectrum due to the universe's expansion that a powerful, dedicated infrared instrument like JWST is necessary to probe them. So, when JWST came along, Sears_1019, the brightest of the Hubble galaxies from this epoch, was an obvious target. The telescope stared at the galaxy for just 1 hour, with all 4 of its instruments, but returned a wealth of data. In the moment I was kind of like, wow, look at everything we can see with JWST. We've seen this whole portion of the spectrum of this galaxy and any galaxies early on in the universe we've never seen before, said astrophysicist Rebecca Lawson. I was just overwhelmed by the amount of information. But then she noticed something she wasn't quite expecting. In addition to the light of star formation, there was a broad emission feature usually associated with AGN. And when she mentioned it to some AGN researchers, things started to get interesting. Typically, a galaxy in the early universe emits either light from an AGN or light from star formation. To see both in the same galaxy was extremely unexpected. There is some impact that the black hole is having on the emission lines that we're seeing, but most of the light we see in our images is still dominated by the star-forming part of the galaxy. That a supermassive black hole existed more than 13.2 billion years ago, and was seen growing, is not as surprising as you might think. Much larger black holes have been detected in the early universe. Scientists still do not know how the black holes in those galaxies got to be so massive, that early on in the universe. What do you guys have to say? We have only recently discovered galaxies that formed only 300 million years after the Big Bang. These galaxies are big and complex, and scientists around the world were baffled, as according to the standard model of cosmology, such galaxies cannot exist so early on. Now, with the discovery of this black hole only some 500 million years after the birth of the universe, the mystery has only deepened.